Hi friends, in this video we learn about modulation index of frequency modulated wave, right? So what is FM? FM is, we know it is a process of changing the uh, frequency of the carrier, in accordance with the message signal, right? In accordance with the message signal, right? In accordance with the message signal. Okay, now we derive the equation for FM. From that we find what is a modulation index. Then we solve one problem from this, right? So the main thing about FM wave is here the frequency of the carrier, right, varies in accordance with especially instantaneous amplitude of message signal, right, or modulating signal. Okay, let us see what will happen here, right? So this can be expressed in mathematically like this. So instantaneous frequency, right? So it is not general frequency, it is the frequency at particular instant. So instantaneous frequency of the carrier is varying in accordance with the, what you call, amplitude of the message, instantaneous amplitude of the message signal. That's what this one. So FM, and in FM, instantaneous frequency Fi is given by Fc carrier frequency plus Kf, which is known as frequency sensitivity, right? So M of t, we know it is a amplitude. It is a message signal whose amplitude we have to take into account. So instantaneous frequency varies linearly with respect to amplitude of the message signal, right? So that's what we are understanding from this, right? So here you see the frequency of the modulator. From this we will understand the frequency of the modulated wave will increase when message signal increase. M of t increases, instantaneous frequency will increase. If M of t decreases, the M of t means amplitude of the message, then Fi also will decrease. Okay, let us see that in detail. So from this what we are understanding, Fi is equal to Fc plus Kf M of t, that is equation number 1. We know instantaneous frequency, angular frequency is equal to rate of change of phase with respect to time, right? So this implies omega is 2 pi Fi, that is equal to d theta I by dt. So this is the relation between phase and frequency. If phase is known, what is frequency? Suppose, how can we get phase from frequency? I have to integrate. If I integrate this one, theta it will become omega I dt. Right? Instead of omega I, so that you can write as 2 pi, omega is 2 pi, Fi is this one. Fc plus Kf M of t dt. Right? So this indicates 2 pi Fc constant. If you integrate dt, t plus 2 pi Kf, 2 pi Kf integral M of t dt. So this is the instantaneous angle of what do you call, FM wave, right? We know any angle modulated signal is given by S of t is equal to A cos theta it. If it is FM, I put S FM of t. Amplitude becomes amplitude of the carrier cos, instead of theta it I write as 2 pi. This is for FM wave. So theta it becomes 2 pi FCT plus 2 pi Kf integral M of t dt. Right? Suppose if M of t is given by Am cos omega mt, then Sfm of t, the Fm signal becomes Ac cos 2 pi Fct plus 2 pi Kf integral m of t is am cos omega m, integral am is constant, so integral cos omega m is sin omega m divided omega mt divided by omega m I write as 2 pi f, right? So this is the equation. If I simplify, what is the fm equation I get? That is given by AC cos 2 pi fct plus 2 pi kf, can 2 pi cancel, so plus kf am divided by fm sin omega mt. Otherwise I can write as sin 2 pi fmt, no problem. Sin 2 pi fmt. So here I take this parameter as beta. So SFM of t equation becomes, what happens is, that is AC cos 2 pi fct plus beta sin 2 pi fmt, where beta is a modulation index of fm. Beta modulation, it is called a modulation index of fm. What is beta? It is kf am divided by 4. This is the modulation index. Kf am I write as del f by, del f is nothing but frequency deviation, right? Fm is maximum frequency of message, right? So your message may have many frequency component, we have to take the maximum frequency of message, right? Okay, this is what modulation index of fm wave. Now we solve the problem. Okay, so what is the question? Consider the frequency modulated signal 10 cos 2 pi into 10 power 5, right? 10 power 5 t, here I put t, plus 5 sin 2 pi into 1500 t plus 7.5 into sin 2 pi 1000 t with the carrier frequency of 10 power 5 hertz. What is the modulation index of FM wave? So that's what they are asking, simple question. So what is that? So FM wave they have given as FM of t is 10 cos 2 pi into 10 power 5 t plus 5 sin 2 pi into 1500 t plus 7.5 sin 2 pi into 1000 t. From this, what are the things we know? This is what amplitude of the carrier. So AC is 10. It is cos 2 pi. Okay, 2 pi will come here, please. 2 cos 2 pi omega c. So FC is 10 power 5 hertz, right? So these are all the things. This is omega ct. I can write as omega ct plus theta it, right? So I want fi. Whenever I want to find the modulation index, so what is modulation index? Beta is equal to kf am by fl, right? Okay, this is the message out of this is carrier. These two are message. Out of these two, which is having highest frequency component, message is 1500 plus 1000. So which is the highest frequency component? 1500. So FM is 1500. Okay. Now what I do? I have angle. So omega c is carrier frequency. I want instantaneous frequency. So what is Fi? This is what theta I. If I want Fi, we know omega I is equal to d theta I by dt. So if I know omega I can find Fi value, right? So d theta I by dt. So this is theta it. If I differentiate this, what I get is omega I. So phi, if you differentiate, this is what theta I, this area, right? So phi sine, if you differentiate, it is 2 pi into 1500 cos 2 pi into 1500 t. If you differentiate this point, it is 7.5 sin 2 pi into 1000, so that will be constant. So 2 pi into 1000 cos 2 pi into 1000 T, right? So what is KFAM? We know our equation is theta I will give KFAM, right? You remember this. You see, whatever things coming nearer to this part is KFAM, right? The numerator part is KFAM. So from this, what we understand is KFAM is, we have two signals, so we have these two parts, KFAM1. Let us consider this is KFAM1. That is 5 into 2 pi into 1500 plus KFAM2, that is this part. So 7.5 into 2 pi into 1000. Right? So this is what omega I want Fi. Fi means, so KFAM1 plus KFAM2 divided by 2 pi. Then only I will get del F value. So what is the thing? It is 2 pi is common for both. So 2 pi 5 into 1500, 7500 plus 7500. This is what 2 pi. So this is KFAM in terms of omega. So I want in terms of F. So it will become this one. So KFAM will be, what is the thing? Total KFAM. KFAM total is 15,000. Right? So now we got KFAM as 15,000. Right? Why we divide by 2 pi, you understand? Because it is in omega I. I want answer in Fi, so it is 15,000. I divide by 2 pi. Right now it is telling that what is my beta value? Beta is equal to del F by F max or Fm. Del F is nothing but KFAM. That is nothing but 15,000. Fm in the initial stage itself we found it is 1500. So 15,000 by 1500 beta is equal to 10. Right? So this is the answer. I hope you understand the concepts. If you have any doubt, please ask me in comment section. I will clarify. Thank you.